Aoyama from the Mobile Architect team. Hello, everybody. We work on the infrastructure for the platform, a really wide range of things. In today's section, we'll be talking not about specific tech, but about just general problem solving perspectives. To start off, what is problem solving actually referred to? This is the definition from Wikipedia. So, problem solving is a process of achieving a goal by overcoming obstacles, a frequent part of most activities. Problems in need of solutions range from simple personal tasks, such as how to turn on an appliance, to complex issues in business and technical fields. Thus, problem solving applies to a wide range of things we do on a daily basis. And within this context of software engineering, this can refer to things like bug fixing, refactoring, performance improvements. So, really, very basic daily things to much more complex tasks, such as designing a new system architecture. Therefore, software engineering is really just all different kinds of problem solving. To solve problems, you have to first understand the problem properly. This is my personal perspective here, but you can break down problem solving into two different types. First is solving negative problems. This refers to actions taken to resolve problems that have already occurred. Looking at the example before, so bug fixes, performance improvements would fall under this category of negative problem solving. One other type is positive problem solving. This is usually the way we refer to it when we say problem solving in Japanese, positive problem solving. In other words, actions taken to solve obstacles to achieving a goal. In negative problem solving, you're trying to take something from a negative state to a net positive state, but positive problem solving is trying to take it from a neutral state to a more positive state. What's really important for negative problem solving is to really get to the root of the problem rather than just take temporary countermeasures. So, more permanent measures are more important here. Without doing so, the actual actions you take can lead to technical debt, even though you were trying to solve this problem. And for positive problem solving, compared to negative problem solving, you need to take a more long term perspective and do things that are a little more sustainable. Without doing so, the action you take for positive problem solving can actually lead to other types of negative problems. It's also important to really take this technical investment perspective for positive problem solving. That refers to thinking of, as an organization, really more long term problem solving. For example, the problem solving approach we might take might end up as legacy tech in the future, or understanding from a more engineering perspective what will be important on the long term. What kind of state do we want to aim for on the long term when thinking of what approach to take. To solve problems, it's important to utilize critical thinking to ensure that you're really perceiving the problem correctly. Critical thinking refers to a way of thinking that provides objective analysis and evaluation without being driven by your own emotions or subjectivity. Don't try to just find reasons for why you might be correct, but really think more to the heart of the problem, the really base nature of the problem. We naturally will only look for things that confirm what we already believe, otherwise known as confirmation bias. So we need to be sure that you're not falling into this pattern of thought. To solve problems, I think you can break down the process into the following steps, these six. The first step is properly understanding the problem and then working to analyze that into more detail. Third, based on that analysis you've conducted, define a goal and any constraints. Once that's been defined, you will look into the potential solutions to solve the given problem. And then evaluate those potential solutions. After doing so, it's important to reflect on the solution, to review it. We have actually rebuilt the entire mobile app here at Mercari before. And one of the biggest motivations to do so was to fix the build speed. I look over iOS, but this issue of slow build, regardless of platform, if you're going to do any sort of compile language, it's a problem that can happen across any platform. To start off, we need to understand the problem. To do so, we need to first ask ourselves, is it a negative or positive problem? And actually understand the impact of whatever that problem might be. That, in other words, refers to what kinds of inconveniences are caused or issues are caused by this problem not being solved. And we also need to identify who are these stakeholders or customers who are affected by this given problem. It's important to also refer to the data to determine the severity of the given problem. This problem was an existing problem in just our daily development. So it's definitely a negative problem. However, it's important to also work to prevent the problem from getting worse. In that sense, it's also a positive problem. Therefore, we need to work on bringing us from a negative state to a neutral state, but also continue to improve on the situation.
And this problem of the slow build speed, To be more specific, this will deteriorate the productivity of all engineers, and also it will deteriorate the product lead time as well. And it also blocks multiple people to work simultaneously. So these were all these problems that could be caused. When I say product lead time, is that once we start the development until the time that it will be delivered to the end user, that part will be called as the product lead time. So for this particular issue, in order to avoid future regressions and a deterioration, we will actually implement a long-term solution rather than putting a temporary improvement. But as I explained, that this problem also has a positive side. Therefore, we will conduct an investigation from the technical aspect as well. But build speed actually impacts significantly to the day-to-day development work for all engineers. So when we think about that scope of impact, we wanted to avoid to introduce something that did not have any precedence. So we were able to fully grasp the problem. So the next step will be to conduct a further analysis on that problem. So when we do analyze a problem, the most important point is to break them up into smaller pieces. The bigger the problem is, the state of that problem or the environment can actually impact the problem itself. So it can be very complex, regardless of how it can be articulated. Therefore, it will be very useful to break them down into smaller problems to better understand and think about the potential solutions. So, however, when it comes to like bug fix, like debugging, which is a rather simpler problem, you may be able to understand the cause based upon the past experience, but it is very important to investigate the root cause to fully understand why that problem arose and fully understand what the nature of that problem is. So, in terms of the slow build performance or speed, the specific issues will be build cache not being used effectively, and also that with the insufficient modules, uh, redundancy in build is occurring, and also using the program syntax that will become an overhead for compile time can be an issue of this. And also another issue would be that the source code is too large. Now, the top two issues, which is not being able to effectively use the build cache and also the less modularization. These two issues is a system related issues, and then it will be able to be solved through a more perpetual solution. So we determine that these are the root causes. And the next two issues, for example, the compile time being the overhead, this requires individual effort. Therefore, we can say that this will not be the root cause of this. And also the code being large, as the product grow, we cannot avoid seeing the source code getting bigger too. So this was not also the actual root cause of this. So we were able to dissect and analyze the problem. So we will define the goal after solving that, and also we will define the constraints. When I say goal, is that what is the to be state once the problem is solved? So that's the goal is, and it is very important to come up with solutions. So the goal has to be very concrete. To give you an example using this case, so build speed being faster is not concrete enough as a goal. So how do we want to achieve that speed in build? We will try to define that more specifically. Similarly, even if we do set an feasible goal, the solutions to achieve that cannot be put together. So the goal has to be a feasible one. And after the solution is implemented, we do want to measure to what extent we're able to achieve the goal. Therefore, the goal shall be something that can be quantified. When I say having a quantitative goal, is that it means that it can be compared. So ideally, it is better to have some kind of a numerical goal. Moving on to constraints. To achieve the goal, what are the criteria that we cannot accept? When we want to realize the goal, we need to bring certain changes. But in those changes, what is the clear threshold or criteria that you want to set so that you will not accept anything that is below that? So, in this step, we will clarify what is absolutely required and what cannot be accepted. So, again, with regards to this problem of slow build speed or performance, we can set goals as follows, such as about reducing time per build by 30% or more, or divide the module into roughly 500 plus to improve the cache efficiency. And this number 500, before rebuilding Mercari, we all had some dozens of modules. However, considering the number of features, we came up with this 500 as a more practical number. And the third point is that to ensure in-depth potence of builds, to have the zero clean builds. So when I to explain this, depending on the environment and such, the result of the build can vary. And when that happens, we will reset the build cache to make it a clean build. And this was the problem that we tend to see on iOS. Therefore, in this goal, we decided to bring this down to 0. And the fourth one, so this was more a stretch goal. So we wanted to make sure that there will be zero redundant builds of the module that have been built somewhere else. Now, in terms of the constraints, we didn't find too many. Therefore, I guess this was not a great example of this part, but to improve the build speed, making a changes to the build system will be a significant impact to the individual developer. And because of that, we didn't want the individual developers not being able to use standard tools. And also, we didn't want to make a negative impact on the programming experience itself. Again, in debugging, which is a much simpler problem, I think we'll be able to come up with more specific constraints. So once we define the goal and the constraints, we will look into the actual solutions to solve the problem. In exploring the potential solutions, I would like to ask you to bear in mind that there is no perfect solutions in most cases, so we should consider multiple alternative solutions always. And in that sense, in that case, we should not be stick to a certain perspective, such as maintainability, feasibility, efficiency, scalability, reliability, usability, evolvability. So there are so many different point of views. So we should not try to stick to just a single perspective among them to come up with a solution, but instead we need to consider potential solutions from various point of view, viewpoints. And it also is important to not rely on to controllable factors. When it comes to a large scale development, individual level effort cannot be reliable. So we should not be dependent on such element, but instead we should try to come up with a solution that is made up about controllable factors. Similarly, it is very difficult to sustain a permanent or constant effort. So if possible, it is better to solve the problem by making changes to the system. And also the solutions, I think we'll be able to reach an optimal solution by having multi-dimensional perspectives. So just like doing a brainstorming, it is very effective to come up with various ideas in the process. So again, going back to this problem of the slow build performance, here are the potential solutions. One is that having a standard tools to modularize, and then we should pre-build stable modules among them and share caches to each engineer via hosting server. Second one is to develop our own build support tool with a smarter cache system in place. And lastly, by using the third-party build systems, we can do the build and use the remote cache feature of that. When I say remote cache, so the cache data that occurs from the build will be uploaded to the hosting server so that the other engineers can repurpose that cache data when they do their development. But of course, there were other multiple the solutions that came up other than these three, but among them, we consider that these three will be viable solutions. Now that we were able to come up with some solutions, the next step will be evaluating those solutions. Now, solutions always come with some trade offs. When I say trade offs, so by solving that particular issue, as a by side effect, we will see some other issues arising or seeing the original state deteriorating. However, normally it will be a smaller problem than the original problem that you faced. So we have to take it into account how to manage the trade-off when we solve a problem. However, that if the trade-off seems to be much greater than the actual improvement, then probably it's better to not to go with that particular solution. And when we evaluate the solutions, then we need to validate against the hypothesis to confirm that that solution will really work.
We've gone over a few of the initial steps for problem solving, but it's pretty hard to come up with a perfect solution through just one time. Therefore, you need to go through this process of PDCA to come to a really solution that you're happy with. First, we look into the potential solutions, evaluate it, and test the hypotheses. Then we need to look at how to make improvements to the parts that didn't go as well as we had hoped. Within the solutions that we looked into before, there's modularization with standard tools, pre-built stable modules, and shared caches to each engineer via hosting server. This is one of the most common ways to solve this problem. We look at the tools that are being developed, and we realized was very few were actually as stable as we had expected. Thus, we had to work on updating the modules, and the solution that we come up with had to be quite complex. For iOS, it was a little difficult to just implement fine-grained modularization with the tools that we already had. The second proposal here of developing our own build support tool, we realized actually implementing many different functions would be quite high in terms of development costs and maintainability, so it was rejected. The third solution was to build a third-party build system and use a remote cache feature. We looked into this and realized that there was enough potential to achieve what we actually hoped to. However, for iOS, Bazel and Buck weren't very common, so we had some concerns about if it would actually be possible. However, for backend, there are a lot of examples to look at. For example, things built in Go, and Google and Lyft, for example, have already succeeded in iOS. And we've seen more and more of these cases recently. Based on this, we conducted a POC to check if our hypothesis was correct, and we're able to be confident that this solution would work. Using a third-party build system includes a trade-off of a pretty high learning curve. However, when it came to actually migrating, we put together a strategy and were able to set it up in advance in a way that would work for everybody. As a result, we decided to go with this solution. Now it's time to review the actual solution. After implementing the solution, we need to go and look at the actual status. We look at the goal that we set for ourselves in step 3 and see the extent to which we have achieved it. We also look at what's the risk of the problem occurring again. and look at what are the remaining problems or trade offs. We also need to think about for development going forward. It's really a great learning opportunity at this stage. Thus, we need to learn from the problem and also think about ways to prevent it from occurring again. Furthermore, it's important to standardize the solution. And after we've implemented the solution, it's important to ensure that it stays in a good status. So that can be partly difficult. Thus, we must keep making improvements. The actual results of taking on Basil, we have put together this blog summarizing our experiences. So please take a look. And to finish up, I will summarize what I've shared today. Problem solving is core to any type of human activity, and software engineering is purely problem solving. Furthermore, critical thinking helps you to objectively look at a problem. It's important to really exercise critical thinking here. Problem solving can be broken down into 6 steps to come to a successful solution. Here are the 6 steps. Again, first is understanding the problem correctly. Second, analyzing the problem into greater detail. Third, defining a goal and constraints based on this analysis that you have conducted. And exploring the potential solutions for the goal that you have defined. After that, we evaluate the solutions to determine which will work the best. After that, we test out the hypotheses and continue the process until it works successfully, after which we review the final solution. In problem solving I conduct on a daily basis, I wouldn't say that I really systematically go through all of these steps. However, the general perspective for problem solving is what I've summarized here in these 6 steps. I hope that this will be helpful for your problem solving going forward. That's all from me today. Thank you very much. Thank you very much.